How's it going? This is your old pal, Mr. Cook. We're going to work on the extra review for Unit 2, Part 1. All right, so Unit 2, Part 1 is going to be about quadratic functions. So a big part of quadratic functions is factoring. So these first four problems are going to deal primarily with just factoring. Now, it should be stated that third one, that one is not going to really be used for our test. So we're going to do a method called factor by grouping on this, but you're not going to have a cubic expression at all on the test. It's all going to be just quadratic. So if you don't quite get how to do number 3, don't worry too much about it. But anyways, number 1, however, is a difference of squares problem. So I know that it's a difference of squares problem because it's a squared x value and a constant, and they're subtracting each other. So the way that we're going to solve this is by going through a simple algorithm of just first checking for a greatest common factor to factor out, and then second factoring. This is going to be true for most of the problems that you look for quadratics, for either factoring or for solving when we get to solving in a little bit. If you can't find the greatest common factor, go to factoring. If factoring doesn't work, then you'd go to quadratic formula. And if that doesn't work for whatever reason, I don't know any instance that it would, then, fourth best would be completing the square. But even then, I would never personally do that for solving ever. So don't put too much stock in completing the square, or don't worry about completing the square too much if you're not really getting it at this point. Anyways, so if we want to factor this, we want to find a greatest common factor first. 3x squared and 48 are both divisible by 3, so I'm going to divide out a 3. So when you divide out a 3 when you're factoring, it goes outside of parentheses. We're just using distributive property in this way. If we divide out the 3 here, we just have an x squared. If we divide out a 3 here, we get 16. And now this becomes a special part of factoring, which is a difference of squares problem. So the way that you do difference of squares in factoring is that you take the square root of the x squared and you take the square root of the 16, and then you have then they're conjugates of each other. So we have 3, and then square root of x squared is just x. The square root of 16 is 4, so we have x minus 4 and also x plus 4. And just like that, we are done factoring. That's the first example. Second example, so I made a video about factoring trinomials, quadratics a little earlier. If you want to go ahead and reference that, you can at this point. Now, this just means we draw the x here, and then our lead coefficient is 1, so 1 times 6 is 6. We need to find two numbers that multiply together to be 6 and add together to be -5. Those two numbers are going to be -2 and -3. So when we factor this out, we get 1x, so x minus 2, and then times 1x minus 3, so x minus 3. And just like that, we are done factoring because we can't go any further with our simplification process. Next, number 3. So this again is one where you can just kind of not put too much stock in it, because again, we're not going to have cubic expressions. It's all going to be quadratics. But factoring by grouping is still pretty easy. You just pick a couple of terms and then group them together, and then find the greatest common factor and then see if it factors after that. So between x to the third and 5x to the second power, they both have x squared in common. So I'm going to divide out x squared from both of these. And if I divide it out using distributive property, it goes outside the parentheses, and x to the third divided by x squared is just x. 5x squared divided by x squared is just a plus 5. All right, so that's the first part of factoring by grouping. Now the other two terms that I have here, -4x and -20 are both divisible by -4, so I divide out a -4. And if I divide out the -4 there, I get a positive x. -20 divided by -4 is a positive 5. And when factoring by grouping works is when you get a factor that's the exact same. So this x plus 5 is the same as this x plus 5, so we're going to factor that now out of our expression. So if x plus 5 goes on the outside of the parentheses, and on the inside of the parentheses we have an x squared and a -4, and now it's a difference of squares problem, so we factor this as well the same way that we did x squared minus 16 over there on number 1. So we should end up with x plus 5 times parentheses, the square root of x squared is x, the square root of 4 is 2, so x minus 2, and its conjugate x plus 2. All right, that's a completely factored expression. This method of factoring is going to help us out a lot in part 2, polynomials. So look forward to using that in the coming weeks. Next, number 4. So we do the x here Numbers that multiply together be 4 times negative 10 is negative 40. So numbers that multiply together to be negative 40 and add together to be negative 3 are middle coefficient. So the numbers that multiply together to be negative 40, add together to be negative 3 are negative 8 and positive 5. Since we have this lead coefficient of 4 on the x squared, that is also going to be prevalent on our x, or present on our x. So we've got 4x minus 8, and then also 4x plus 5. Now we're going to divide out a common factor from both of these. The number that divides into 4 and 8 is going to be 4. The number that divides into 5 and 4 is 1. So if I divide out the 4's here, 4 divided by 4 is 1, so I have 1x. 8 divided by 4 is 2, so minus 2. And then if I divide anything by 1, it's just itself, so I just get a 4x plus 5 for that second binomial. Okay, so that's factoring. If you have any additional questions, you can refer back to the earlier factoring videos, or just look for some other videos on YouTube. They have a ton on all these different ways of factoring. Next up, so it says solve each of the following quadratic equations using the method stated. So here's the deal. On the test, it's not going to be the method stated. It's going to be using any method. But this is still good practice, factoring, the square root method, completing the square and quadratic formula. Just good practice to do the different methods. The more fluent you are in the different methods for solving, the easier the math comes to you. So just keep practicing these, and it makes it a lot easier. But anyways, if we have this expression, if we want to solve it by factoring, then we make the x numbers that multiply together to be 1 times 64, so 64, and add together to be 16. So those two numbers are going to be 8 and 8. So this factors to become x plus 8 times x plus 8. And if we take the factors and set them equal to 0, they're the same factors, so I can just do it once. X plus 8 equals 0 means that my solution, my lone solution, is going to be x is equal to negative 8. For number 6, square root method. So the square root method works for any difference of squares, or any, it could even have addition in between, so the sum of squares as well. But it always works the same way. It's going to be an x squared and a constant, and this is how you solve it. You just use order of operations. So you want to get the x squared by itself. So to do that, we need to subtract 24 from both sides first. So we get 3x squared is equal to negative 24. Divide both sides by 3. X squared is equal to negative 8. And then take the square root of both sides. So that means that x is going to be equal to plus or minus the square root of negative 8. Now, that plus or minus is very important, and the way that we get it is that whenever we take the square root of a squared variable, we have the positive and negative solutions that account for that. And it's because of the way that x squared works, because x squared is a number times itself. So if I had a positive number times itself, it would give me this, and also a negative number times itself, it would give me the same answer. But again, we also are dealing with imaginary numbers here, so since we have a negative under the square root, it just simply goes outside the square root and becomes the imaginary number I. So to further simplify this, we get x is equal to plus or minus I times the square root of 8. But wait, there's more. We can simplify this a little bit further, because 8 is the same as saying 4 times 2. And if I take the square root of 4 times 2, I can take the square root of 4, because the square root of 4 is 2, so this becomes 2 radical 2. So I can even rewrite it a little bit more simplified as x is equal to plus or minus I times 2 times the square root of 2. Or as I like to write it, I like to keep the I closest to the radical, so I like to write it out like 2I square root of 2. So that'd be your simplified expression. I'm pretty sure that most teachers would probably just expect you to find it up to this point. If you want to reduce the radical, you can. I don't know if you'll get any extra credit points or anything like that, but that's how you would reduce it a little bit further. Number 7, completing the square. So a little bit about completing the square. I'm not particularly fond of this method of solving. I think that quadratic formula seems to kind of make everything a little bit easier instead of completing the square, even though it's the same relative process. It's just not so intuitive, completing the square as quadratic formula is. Quadratic formula is just find a, b, and c and plug it into a formula. This one takes a bunch of steps to get to the same solution. Anyways, completing the square is easy if you know the steps. But if you're not really comfortable with it, don't worry about it right now. Just concentrate on like factoring and quadratic formula and square root method. But completing the square, pretty easy. I just get the constant value over on the other side, so minus 4 on both sides, and I get x squared minus 10x is equal to negative 4. Then I make a perfect square out of this. So to make the perfect square out of this, I need to add in a specific value that turns this into a perfect square. And if I add it on this side, I also need to add it in over here. So to find that specific value, it's really easy. You just take the b value, which is -10, and divide it by 2. So negative 10 divided by 2 is -5, and then you simply square it. So that's what you need to do on both sides. Just take that number and square it. This turns into a perfect square. It becomes x, and then whatever you got over here, that b value divided by 2, what was it again? It was -10 divided by 2 is -5, so you write x minus 5 there. Squared is equal to -4. And then -5 squared is 25, so then plus 25. So then we get x minus 5 squared is equal to 25 minus 4 is 21. And then you follow order of operations to get x by itself. So take the square root of both sides. So I get x minus 5 is equal to the square root of 21. And since I took the square root of a squared variable, even if it has that -5 or whatever on it, you still need to put the plus or minus in front of that radical. So next, get x by itself by adding 5 to both sides, and you get your answers. 5 plus square root of 21 and 5 minus square root of 21. Or if you just simply write it out as 5 plus or minus square root of 21, you'll get probably full credit for that. With quadratic formula, so all that you need to do for this is label your a, b, and c values. A equals 5, b equals -7, c equals 8, and then plug it into the quadratic formula. So the quadratic formula looks like this. Your solutions to the expression x are going to be equal to -b plus or minus the square root of b squared minus 4ac all over 2a. All right, so we plug those numbers in, and this is a really easy way to get partial credit. I can't stress this enough. Just plug in a, b, and c into here, and it'll be really easy, okay? So if I plug those in, I get negative of b, which is -7, plus or minus the square root of -7 squared minus 4 times a, which is 5, times c, which is 8. I know it's a pain in the butt to write up all the parentheses and everything, but it helps out a lot, and it allows you to type in an expression directly to your calculator and get the right answer. Speaking of which, let's go ahead and use our calculator when we need to do this part under the square root, because as long as we keep those parentheses there, we'll get the right answer. So let's see here. Let's try and do a little bit of it by hand. So the opposite of -7 is a +7. And then in the denominator, I can put 10. And I've seen a couple kids do this. Make sure that the 10 is the denominator for the entire fraction, so the whole top part, okay? Not just the radical, not just the b, the entire part of it, okay? And then plus or minus the square root of, and let's see, that's 49, and then that's -160, so I think it's -111. Let's double check that. Okay, so if I type this into my calculator, parentheses -7, parentheses squared, minus 4 times parentheses 5 times parentheses 8. Yep, -111. So as long as I have the parentheses in there, I'll get the right answer every single time. Now, 111 is divisible by 3, so let's see if I can simplify this expression a little bit more. 111 divided by 3 is 37, okay? So 37 is prime, so it's not like we can reduce this radical anymore, but there's one more thing that you need to do, and that's get this negative out of here. Just turn this into a complex number. So if we have the square root of a negative, we move the negative out front, it becomes an I, so that'll give us our solutions. X is equal to 7 plus or minus I times the square root of 111 over 10. That's your answer. It looks kind of ugly, but you know, it is what it is. That's your answer. All right, so that concludes this part of it. Now let's do the complex numbers. So when you need to find the sum or the difference, you're really just combining like terms. So let's write it out. If we're adding these two together, let's see, we've got 2 minus 4i plus 3 plus 5i. All right, so when you're adding, just get rid of the parentheses. You don't have to really do anything with those parentheses at all. You can just, combine like terms. 2 plus 3 is 5, so 5. Negative 4i plus 5i is a positive 1i. And then you're done with your complex number. Make sure to put it in the proper notation with the real number first and then the imaginary number second. That's how we write out complex numbers. Difference? Well, this doesn't really say which one goes first, so I'll just do the first one. So 2 minus 4i, and then, difference. So we got to subtract minus, and then it's going to be 3 plus 5i. So the reason you keep the parentheses here is because with this negative, you need to distribute it to both terms. Take your time with this. Distribute both negatives. Don't just subtract 3 and think that you're going to add 5i at the very end there. You're not. make sure that you distribute the negative and rewrite it. So we get 2 minus 4i minus 3, and then the negative also distributes to the 5i, and we get a minus 5i there as well. Make sure to take your time on this. You're going to feel like an idiot if you write this stuff out and then you get the wrong answer. So just combine like terms from here. So 2 minus 3 is negative 1. Negative 4 and negative 5 makes a negative 9, so negative 9i. And there's our difference. Now for the product, we're just going to FOIL or distribute. So multiplying these together, 2 minus 4i times 3 plus 5i. So if I FOIL, so first number, outer number, inner number, last number, etc. So 2 times 3 is 6. 2 times 5i is a positive 10i. And then negative 4 distributes on those. So negative 4i times 3 is a negative 12i. Negative 4 times positive 5 is negative 20. And I times I is I squared. And we know what I squared turns into, right? Turns into a negative 1. So then we get 6. And then 10 minus 2 is negative 2, so negative 2i. And then negative 20 times negative 1 is a positive 20. So we just combine like terms. 6 and 20 gives us 26. So we have 26 minus 2i. And that's the complex number that we get as a product. Now for the quotient. So the quotient, again, I don't know which is going to divide by which, so I'll just do this one, divide by that one. So 2 minus 4i over 3 plus 5i. So when you're dividing two complex numbers, what you do is that you need to multiply by the denominator's complex conjugate. So we're going to multiply the top and the bottom by 3 minus 5i. So then it's just a practice, product, multiplying for both of these. So, just get some practice in with that. If we distribute these together, 3 times 2 is 6. 2 times negative 5i is negative 10i. Negative 4 times 3 is a negative 12i. And then negative 4 times negative 5 is a positive 20. And then I times I is I squared, and we know that I squared is negative 1. Foiling this in, we get 3 times 3, which is 9. 3 times negative 5, which is negative 15i. 5i times 3 is a positive 15i. And then 5 times negative 5 is negative 25. And then we have I times I, which is I squared, which is secretly negative 1. Now, the nice thing about multiplying conjugates is that it cancels out the middle terms, so those i's are going to go away. And let's see what we end up with in the bottom. So it's going to be 9 plus 25, which is a positive 34. And then in the top, we've got 6 minus 20, which is going to be a negative 14. And then negative 10i and negative 12i is a negative 22i. And I notice right off the bat that 14, 34, and 22 are all divisible by 2, so I divide everything by 2, and I get my answer, which is negative 7 minus 11i. And then that's all over 34 divided by 2, which is 17. So there's my complex solution there. And then, of course, you can check your work on your calculator if you want, but that's what you would need to show for credit. It looks like we have a couple more expressions to work on here. Let's practice them. So we've got 3 minus 2i plus 2 plus 3i. Since we're adding, we can just get rid of the parentheses and then just evaluate. So 3 plus 2 is 5. Negative 2i plus 3i is a positive 1i. So we end up with the same answer that we started with over here. For b, we're multiplying, so we FOIL. 5 times 5 is 25. And these are conjugates of each other, so the middle terms are going to cancel out. So all I really need to do is just multiply these together now. So 2 times negative 2 is a negative 4, and I times I is I squared, which is negative 1. So we get 25 plus 4, which is 29. So 29 is our answer there. Part C, we have division, so we multiply both the numerator and denominator by the complex conjugate, which is going to be 4 minus 2i. So multiplying straight across here, we get, let's see here, 3 times 4 is 12. 3 times negative 2 is negative 6. Negative 1 times 4 is a negative 4. Negative 1 times negative 2 is a positive 2, and then it's I squared, which is a negative 1. And then in the denominator, we get 4 times 4, which is 16. The middle terms will cancel out. And then 2 times negative 2 is negative 4, and then I squared, which is negative 1. So we end up with 12 minus 2, so 10. Negative 4 and negative 6 makes a negative 10i. And then in the bottom, we've got 16 plus 4, which is 20. All of these divide by 10, and I end up with 1 minus I over 2. Beautiful. All right, so that's part C of number 10. Now let's do part D. So before we multiply, we need to get rid of these I values, so we move both of those up to the front. So we have I times the square root of 3 times I times the square root of 8. I times I is I squared, and we know that I squared turns into -1, so we're going to get a negative answer in a little bit. And then we can combine these radicals as well, 3 times 8. So we end up with -1 times the square root of 24. And 24 I know is divisible by 4, so I can reduce this a little further. So I get negative square root of 4 times 6, and the square root of 4 is 2, so I get -2 radical 6 for my answer. And that is all of page 1 for the extra review. On the second page, we're going to make a separate video. That's going to focus on graphing mostly, and it looks like a word problem. So look forward to watching that one. Thank you.